Hey, thanks for coming by. Today I am messing around with some driver circuitry. And I figured maybe I'll take this opportunity to talk about how this common emitter driver circuit works. And you're like, all right, well, what the hell are you talking about? All right, so what I'm referring to is, let me stabilize the camera because it's going to get me annoyed, right? Forget about No, forget about me. It's going to get you annoyed. So let me just calm this camera down here. I got manual focus, so that's also going to mess me up if I keep moving. Okay, so that's better, right? All right. So the question is, I'm going to move a little bit. So the question is, and I'm going to mess with the focus a little bit. The question is, I keep starting the same sentence, is that, so you have a module, some sort of computer module, typically a car computer, but it could be any kind of device. This right here, by the way, is a Wi-Fi. I'm wearing gloves because my hands were all chapped up, and see how we're all zoomed in. It's not that bad, but it's just a distraction. So this is just a Wi-Fi device that it's incidental what this is, but it is a digital device that we want to have control something like a light bulb. And you look at this, and this particular Wi-Fi device, like a lot of car controllers, operates on 3.3 volts. Typically, you're going to have 5 or 3.3 volts as your digital voltage. I'm going to take a sip of my coffee. Excuse me. 3.3 or 5 volts, and they're going to be running at a minimal amount of current. They're going to be using a lot of current because actually computers are nothing but in some cases, yeah, millions of parallel circuits. Just parallel circuits, and parallel circuits means lots of current. In this case, this actually does use a little bit of current, but nothing like what this uses. This uses an amp, by the way. Right, so here's what we do. Caveman, we're just going to come over here, like, how does this work? How does a light bulb work, right? Jokes about light bulb. You plug it in. And what I did, if you notice, what I did there is I grounded it. And who cares whether I ground it or if it's grounded and plugged into the positive? It kind of doesn't matter. But actually, in this case, it does matter. And this is what the common emitter deal has to do with. Without getting into because I have drawings and stuff of the circuits, the common emitter is basically saying, you, Mr. 3.3 volt, whatever, and you, Mrs. Big Booyak 13 volts, you're both going to share a common ground. And what this will do is this will use this circuitry over here to basically say, boom, you're grounded, right? So what we want to do is we want to have this thing tell some circuitry to ground that light bulb. That's the common emitter. That's the whole thing. When you hear common emitter, that's what that's all about, because this is not up at 13 volts, right? This right here is 13 volts. So, and you'll see that in cars. Well, let's say 12 volts. We're going to say 12 volts from here on in. This is like 13, but we'll say 12, right? For a car, we're talking basically like a car. You'll see things that are pinned at 12 volts. You're like, wait a minute, how can you turn this on and off when the thing is directly wired? Isn't it powered all the time? Well, is this light bulb powered? Obviously not. But it is connected. And what voltage do you think that you'll get if you measure this? You'll get 12 volts at the end of this. Okay? That's actually how a computer can know. Because if this is broken, that's a whole other deal. Basically, what a computer can do is it can test the continuity in here. If this has good continuity, this, even at varying resistances, this is going to be the same as this voltage. If there's no current flowing through this voltage is going to be at this voltage, but that's a bunch of theoretical crap. But anyway, what we do is any computer module is not living up in the land of 13 voltness, right? Nobody lives up there, but everybody lives in the land of groundness. Right? So a common emitter deal is where the brains say, hey, you know what? I'm going to get together with some of my transistor buddies, and we're going to pull your ass to ground. And that's how we're going to control a system. Okay, so let's plug it into the output. Now, basically, where I'm plugging it in, all right, maybe I'm just let me, oh, man. So you got to use like utensils, like something like this. I'm plugging it into the middle Now what I do, I bent that around. I'm plugging it into the middle pin of that MOSFET, that big transistor. Oh. I'm plugging it into the MOSFET, into the gate of the MOSFET. The gate is simply the controlling pin. Look, basically, this is a MOSFET. This is obviously the heatsink because it expects to put a bunch of power through it. This pin, the drain, think of a drain, right? The current, where does the current go? The current wants to go, okay, forget about you people who are too smart. We know conventional current, the electrons go from negative to positive, but we're going to call current positive to negative, okay? So basically current goes positive to negative. So when you have a MOSFET, the drain is where the current is going to go out of. And the source, which is what we're plugged into, ignore this. Actually, in this, you can ignore this diode because it has no effect. It's plugged in backwards here. This source here, where we're plugged in, is actually going to be where this is going to be a positive part, right? Because this thing is plugged into positive. So the positive current flow, well, the current flow is going to flow, the conventional current flow is going to flow down through into this MOSFET through this wire. So this is the source. So the source is here, it drains into the ground, and it's controlled through this right here, which basically no current flows between this gate. The gate and the rest of this, I'm just giving you a little bit more detail than maybe you need to know. But basically, this is like this little kind of tiny signal here that controls this. And basically, I can demonstrate that by just blowing through these two transistor circuits. Basically, why I have two transistor circuits here is the output inverts out of one, and then you hook up another one, and then that inverts the inverted output. So by the time it gets to your big transistor, it's in phase. Does that make sense? Right? So these are two inverting, right? The input puts a positive output. Positive output is giving me a negative output. Wait a minute. No, the positive input to the first one gives me a negative. It's, oh my goodness gracious. All I'm saying is whatever the input to this first one is opposite at its output, and it's the same for this one. So the input is the same as the second one's output. Duh. I know. I'm freaking, you know what the word is. There's something wrong with me. All right. So basically what this resistor here is, this is a 56K resistor. And this is sort of just a wire. There's no reason it's looped. It's just there's nothing to that loop. It's just looped for distance. And this is 5 volts here. First of all, this up here where this is 13 is isolated to this quarter of the board, right? All this other stuff, this circuitry back here, by the way, you're supposed to ignore. This has nothing to do with anything in this video. So ignore that. Try to ignore that. Wonderful stuff to talk about here, but ignore that. Anyway, so what we're doing is now I'm manually controlling this light bulb. I gotta back away a little bit. So what I'll do is I'm touching 5 volts with this resistor over here. Now, if you know Ohm's law, if you just without understanding anything, if this is 5, you gotta just trust me with the voltages. This is 5 voltages. I'm drunk, right? If this is 5 volts and this is 56,000 ohms, then the amperage is gonna be what, on the order like less than a milliamp? I don't know, microamps. It's gonna be on the order of microamps. It's gonna be a tiny, tiny current. So the nice thing is we already are set up now where, you know, you won't see any sparks or anything here. This could actually be a nice soft little button, you know, that controls this. So basically this circuit without any computer, and what I'm going to do is I'm going to hook this up so we can see it in action. But before we do that, right, we're on the outside of the computer. So basically what we know is we know that there's a circuit, and this circuit may be inside the computer, by the way. So, the way to troubleshoot it is, basically you just need to know that your output device is working, and you're going to want to know that it's getting grounded. So you're going to want to be able to see when this thing's on, that whatever you're using, that you're getting a current, that this thing is in fact grounding. That's basically what you're testing. If this is outside of the computer, a lot of times the computer, like in my case, here, let me just cut to the chase here. I have this module. It's like, remember Julia Childs? When she would make it, they just happen to have it cooked and ready over here and take it out of the oven. Well, this is the same thing. Oh, I broke it. See, I gotta talk shit, right? See that? I broke it. I gotta talk shit. Look at that. What a moron. Oh, my goodness. Did I break? Oh, no. Okay, so I don't care about that one, actually. So anyway, and just like Julia Childs, too, right? Like, she'll drop stuff on the floor. Oh, because I need the brown one, actually. Oh, so what we'll do here is we'll just plug this in over here, and we'll make sure we don't touch anything else with that wire. Okay? And then we'll plug this in over here. You guys know who Julia Childs is, right? Ground ABC. You know who Julia Childs is, right? If you don't know who Julia Childs is, you guys are like, what is this guy talking about? All right, let me plug this in. Okay, now, what I have done here is I plugged in this module, which I've already done a bunch of work with and configured. And notice what I did is I pulled my little, crap, where did it go? I pulled my little green plug out of there. Remember I just showed you? I pulled this out of here, and then I plugged this wire, which was the unbroken one. Oh, jeez, take it easy. Now this computer is the input to this, and let's see if this works. Now, I just happen to have over here, like Julia Childs. I just opened up my application and I wrote you can see, if you know my OBD2, you know I stole this. So let's see if this turns on. Oh, look at that. Did you see that? Right? And then I can set the level to like 30%. Look at this, man. I set the level to like 12%. Can't even see the light bulb. And turn that off. Can't even see. I can turn it all the way on. Set it to a certain level. Now this is the pulse width modulation. If you saw my other video on pulse width modulation, it might make sense that a light bulb, the regular incandescent light bulb, is much nicer with a dimmer when you're using pulse width modulation to control the dimming of it. But basically what we got over here is we have this module, and it's controlling. Okay, let me explain what's happening here. I got this computer module, and what it is it's sharing its ground. When I plugged it in, basically it got power and ground. The other two pins are ignored. And then I just had this one signal wire in here. And this signal wire is either 3.3 volts or 0. So this 3.3 volts being high right now, being high right now, turns that light bulb on. When I come in and I set my app off, then this, you can't see it, but the 3 point, oh, by the way, this blue LED on this board here, on the board, right, where I'm pointing to, that does the opposite of what my actual output does. I have two different types of these boards. Some of them have that LED. I don't like that LED at all. I don't why. That's distracting for me to see that. And it's the opposite of what the even as I set the level, it goes like to the opposite. So I really think it's so that experimenters can take it out of the box and sort of put in a stock, and you can see this LED blink on and off, you know. But in use, it's kind of stupid. I don't like that light coming on. So I would probably unsolder that if I was putting it into something I was going to use. Okay, so So how do you troubleshoot this, right? So a car is running and the light bulb is on and it's off and it's on and it's being controlled. Basically, it's being controlled by this very low voltage output. Now, this may be inside your computer. Now, the thing is, basically what you got here is you got 3 stages, right? You got your little thinking stage, and your 3.3 volts basically stops here. Okay? These are all biased or hooked up to the 13-volt rail here. And basically, this is our 2 inverting stages, so them together is really just one, positive stage that just sends the signal as is across. And then this, of course, is the on-off control. And you can't tell, but after a while, this will start to get pretty dang hot. This is actually only an amp, so that's why you'll see stuff like this actually maybe mounted to your chassis of your car. But this actually is positive voltage here, by the way. So you'll see weird insulating screws and things like that. You see, it's amazing. They'll be mounted to a heat sink with a, what is it? What is that stuff? It's almost like ceramic right behind here, so that there's no actual connection, but you need the heat sink, so it'll be on there like this, and it'll have this plastic, and you'll see transistors connected to heat sink, and this format of a transistor or a MOSFET or whatever. It could be a voltage. This guy's a voltage regulator of the same format, connected to a heat sink, and completely electrically insulated from your heatsink. That's a trip when you see that, because you need that heatsink. But that's pretty trippy. That's not happening here, but it might have to, because this is positive. That's not really a nice thing, right? So when you're troubleshooting, this is just good to understand that basically the circuit, the power, the muscle, right? You got muscle and you got brains. And the brains, just like your body, is connected at some point to your muscles. But your muscles are coming off of reserve, your muscles. Actually, that's not true. I don't know. I'm not a doctor. Actually, but your voltage is coming off of the reserve here of your, the voltage that's powering this is really, it's not coming out of your brains. It's coming off the rail. And your brains are telling these transistors to come on and off. And in a really nice way. Now, the purpose of the diode here is basically, if you have a motor on here, when you shut off a motor, any kind of a coil, when you're sending current through it, when you immediately cut that connection, the coil will attempt to maintain the current as it was, right? So, but you just shut it off. So it's like there's no current, but the coil's like, no, I want to maintain what I had. So what you'll see is the coil will generate a really high voltage spike. That's how we create sparks and spark plugs. So what'll happen is and the faster you disconnect from a coil that has current flowing in it, the sharper and higher the spike will be. So what you do is you put and it'll be in the opposite direction of everything. So you put this diode upside down in the circuit, so that when this thing shuts off, this is not a coil, so it's not even really happening here. This thing will shoot back a voltage that will just get shorted out right across that diode, because it'll be in the opposite direction. What do they call it? Counter EMF or whatever? Well, it's not really, actually, whatever. So basically, it's really simple what's going on in a driver circuit, in a common emitter driver circuit. You got your brains and your brawn, and they're sharing ground. The brains is telling the brawn through a voltage up or down, I want you to connect this load to ground. And the thing that makes it a common emitter is that it's being grounded, right? Because you could have like the alternative is like a relay, which actually you don't care where ground or positive or anything are, but you might think typically, like, when you connect something, you typically ground it first and then you connect the positive. The positive, right? This is the positive. You would ground something. What I mean is, if I was just in conventional thinking, right? Even me, but if I'm just connecting something, I'll connect the ground first, right? And then go ahead. This wire's a pain in the ass, so I'm not pulling it out, but because it's all stranded. But if you pull out, you connect the ground, then you connect the positive, and you're like, okay, good. And then you would think, like, if you're going to turn it on and off, you would connect or disconnect the positive. So it's counterintuitive what the common emitter does. Here, I'm going to use my thing over here. So by sharing a ground between your brains and your brawn or your power. Here, I like this when it's dimmed up. Oh, this is Xamarin, by the way. But I just wanted to demonstrate the real, like, not just like on paper or something, but the real, how a driver, how something so small and fragile and it's weak, right? In one sense, these are both weak and strong in one sense, right? The weakness here is it doesn't have a lot of power. The strength is it's really smart. It communicates wirelessly with stuff, right? That's way smarter than this driver circuit. This driver circuit, its weakness is it's dumb, or maybe it's strength, but it's dumb. It doesn't know anything, and it's but its strength is that it powers stuff, right? Even if I didn't have we didn't have this board here. If we didn't have this board here, this brain, we could still just turn this on and off through just connecting this resistor over here to ground. So I don't know. I don't know if you got anything out of that. I guess it helps me think because I'm working on some other stuff. And I have to do my other thing. Anyway, now I'm daydreaming in the middle of recording this video. Okay, so I hope that was cool, man. On my other channel, Thought Pill, I am going to go into detail into the circuitry. So if you want to see that, you're going to have to go, I don't know, just find that channel if you care. Man, it's like the channel I make for, like, if hopefully maybe somebody will hire me for a job or something, so it's just all, Mr. Nice Guy projects and more detail, actually. So this is, anyway, I'm babbling, and when I babble, it's time for me to exit and shut the hell up. So, if you have stayed this long, man, thank you very much. And for everybody who's subscribed, man, thank you. It's just cool when you do stuff and people are like, yeah, So, I don't know what's interesting. I think I have to do some work on my OBD2 CAN stuff, so I will be getting to that next. Actually, I'm gonna have to make a video about the detail. I'll just give you an idea, right? Like, here is the circuitry, here's the driver circuit, right? I had to write it out because I'm like all whacked out trying to figure out what's going on. Anyway, so I'm gonna do that. I don't know if it'll be available, but I mean, at the end of this video. So, all right, I am definitely talking too much. So thank you for staying, and have a great day.